So last video was for odd powers. Now we're doing even powers for our sine and cosine. So when we have even powers, we're going to be using our double angle identities, because that way we can take our square and convert it into a not square. Remember, we need the derivative for sine is cosine, so the integral of cosine, right, is sine. So we need to have that no exponent on there. So it's very quick. We take our sine squared and we just say, well, that's 1 minus cosine 2 theta over 2 d theta. And then we put the half in front. And we're ready to go. This is it. No u substitution, no nothing. So the first one's just x, or theta in this case, minus, and then you remember we put a half sine 2 theta. And you always want to just take the derivative to recheck it. So theta's derivative is 1. And then the derivative of this would be cosine 2 theta, right? No sign change. And then you multiply it by 2. And then that 2 cancels with the half. We're back to here. And we put our half. And we put plus c. Okay, so this would be 1/2 theta minus 1/4 sine 2 theta plus c. See, it's nice. So that double angle identity just allows us to change it. So what if you have cosine to the 4th? Well, you change it to cosine squared theta squared d theta. And then you plug it in that way. So with cosine squared, it's got a plus on there. So this becomes the integral of 1 plus cosine 2 theta over 2. And then now we end up with 1/4. And we're going to square the top. So that's 1 plus 2 cosine 2 theta plus cosine squared 2 theta d theta. And you go, oh, there's a square. Well, we just do it again. So this would become 1/4. In fact, I can actually write it down there, and I think I'm going to do that. So let me shrink this a bit. Come back and grab the theta. All right. This is 1/4 integral 1 plus 2 cosine 2 theta plus, and then we do it again. So this is 1 plus cosine, but you remember before, this is 2 theta, right? So when you double it, it's just going to become 4 theta over 2. d theta, like that. So if you look at our little formula right here, you're just plugging in whatever here, whatever you get for this. So if this is theta, we get 2 times theta. If this is 2 theta, we get 2 times 2 theta, which is 4 theta. All right. So we have 1/4. Let me just do some little simplifying now. So 1 plus 2 cosine 2 theta plus 1/2 plus 1/2 cosine 4 theta d theta. And then we're going to add the 1/2 and the 1 together to make 3/2. All right. Now we can take our integral. So this is 3/2 theta plus 2 over 2 sine 2 theta plus 1/2 times 4. So that's going to be, I'm just going to put 1/4 sine 4 theta plus c. And then everything's going to get a 1/4. So we'll put it like that. So let's double check everything. Derivative of 3/2 theta is 3/2. Derivative of sine 2 theta would be cosine 2 theta times 2. So right there, it all cancels. We can actually just rewrite it like that. And so it would be cosine 2 theta times 2, checks perfectly. And then this would be cosine 4 theta times 4, and that cancels with the 4, taking us back. Everything looks good. All right, so let's distribute the 4th. So this is 3/8 theta plus 1/4 sine 2 theta plus, all right, so this is a 4 times a 4, that's 1632. Plus c. Okay, so that was a crazy one there. All right. A lot of multiplying. All right, so our next one. You can look here and you see sine squared and cosine. So you could replace both of them, but I want to do this a little different just so that you have another tool in your toolbox. And we're going to use the sine 2 theta is equal to 2 sine theta cosine theta. So if we modify that, we end up with this. Sine 2 theta over 2 is equal to sine theta cosine theta. So when you see sine cosine together and they're both equally distributed like we have here, we can try this one instead. So we go integral 0 to pi over 2, and we're going to put them together. So sine t cosine t squared dt. And so what we just did was rewrote it so that we can use that double angle identity. So sine theta cosine theta is sine 2 theta over 2. So this is sine 2t over 2 squared. And so now we can distribute that square and we get 1/4, 0 to pi over 2. Oops, why am I putting a parenthesis? Sine squared 2t dt. And so now you can see it looks a lot nicer. We've gotten rid of one of the squares because we had two sets of squares there, and now we're down to one. So if we go back to our double angle identities, you can see that we can apply this one. So sine squared theta is that. So we're going to do that same double thing we did here. If I plug in 2, it's going to become 4. So this will become the 1, sorry, let me just leave it here, 1 minus cosine 4t over 2. So let me zoom in. So it's, since this is a 2t here, it would become 1 minus cosine 4t over 2. All right, so 1/4, 0 to pi over 2, 1 minus cosine 4t over 2. And so we'll pull that 2 out, and now it becomes 1/8, 1 minus cosine 4t dt. And then now we just have to integrate. So this is t minus, and then again it's 1/4 sine 4t. We're not putting plus c this time. There's an 1/8 in front, so we're just going to wait to the end to put that in. But now we need to do pi over 2 and 0. So you still have definite integrals that you're going to have to evaluate as well. So we have 1/8, big old bracket, that's a 5th. Now it's an 1/8. All right, pi over 2 minus 1/4 sine, and then 4 times pi over 2 would be 2 pi, minus, and then it's, we'll just put a parenthesis, sorry, let me just do this again, parenthesis, minus, parenthesis, there we go, that looks better. 0 minus 1/4 sine of 0. With trig functions, you always want to check them because remember, things like cosine of 0 is 1, so you don't want to miss that. All right, so now we end up with, well, this is 0, this is 0, and so it's really just pi over 2. That's all that's left with the 8. So we get 1/8 times pi over 2, which is pi over 16. And always make sure you check your definite integrals. So in our calculator, everything checks perfectly. Pi over 16 is the same thing. So there you have it. So if you have an even sine and cosine, this is what you want to use, double angles.